Okay, last class we have talked about this how all these process the special properties of this lead, right? So in short so again term silver actually silver salt silver silver sulfate only slightly soluble in water means that half soluble when you mix it inside. Okay, it will solid a bit, but most of it will still condense at the bottom. Okay, so and for lead chloride, lead bromide, and lead iodide salt are soluble in hot water. When cooled down, the precipitate, okay, white for the lead chloride or lead bromide, and yellow for lead iodide are formed. And silver chloride are white precipitate. Silver bromide light with light yellow, and silver iodide is yellow precipitate. These are the color that you have to remember, right? Okay, this one only. This one just now we have already mentioned last class. So try to jot down this one. Done, all right. So next. Okay, so let's see the preparation of this soluble salt. So the choosing the method of salt preparation, actually we are following the solubility of salt in water and what type of salt that we want to prepare. So for the salt that related to ammonium, sodium, and potassium, which is soluble salt, so we are using the neutralization reaction between the acid and alkaline. For other than this, okay, we are using the reaction between the acid and reactive metal, acid and oxide metal, acid and carbonate metal. Metal carbonate actually. Okay, if later on you jot down metal oxide and metal carbonate. Okay, so for non-soluble, we are using the double decomposition reaction, which is sometimes we also call precipitation method, where you see what they do is first they use a solution of salt A, okay, combined with solution of salt B, then A and B like AB plus BC, AB plus CD, it will become AD plus BC. No, CB, like that. Means that, where else my pen? It's okay, I just use. It's like AB plus CD. Now, this one, they will become A and D plus C and D. You see? You understand for this one? So then this AD and CB, right, must be one of them is insoluble. So it will become like that. You understand? Means that they are using the substitution reaction. Okay? Now for this one, neutralization, easy lah. They are using the pipette and burette, okay, of acid into the alkali. For this one, we are using the what you call that the process. We are just adding the metal, okay, into the acid. Yes, into acid solution. But the metal must be excessive. Okay, can you understand? Why we need excessive metal? To make sure that all acid has been neutralized or has been substituted into salt. Okay, that's why they need excessive solid metal oxide. Can I? Can understand? Can I sure? Like because what we want to do is we want to make sure acid become the soluble salt. So we give excessive metal, and excessive metal is non-soluble normally. So we add all inside, make it all of the acid has been neutralized into salt, and then the leftover just the solid. So we just filter out the solid leftover, so it will become the solution. Can you understand? All right. You jot this down first. You jot this down together with this drawing. Later I will scroll down a bit. You draw like this. Okay. Done, huh? All right. Okay. Draw this one as well. Then we go to the next one, huh? Okay. Okay. All right. So let's see the next one. So the preparation of soluble ammonium, sodium, and potassium salt. So we are using the titration method, like just how I mentioned. To prepare this one, we are using the titration method, where the reaction between the acid and alkaline, we call it as neutralization. Okay. So normally what we use is like, okay, like for example, when you're using sodium chloride with sodium hydroxide, and then the no, if you want to get sodium chloride, so we will use sodium hydroxide with hydrochloric acid, so it will become sodium chloride in aqueous with water. Okay. Why we call neutralization? Because neutralization always is acid with base become salt and water. Okay. So this is the first process. You jot down this one, and then for the example, right, you only draw this one. Because I think you can understand, you can see HCl, you know, is acid. Sodium hydroxide is alkali, should be no nowadays. Okay. Just jot down the back one only, no need copy so much. Okay, now let's see the next one. Like potassium hydroxide with nitric acid, it will become potassium nitrate with water. So you see, like if we want to get metal nitrate, so we use nitric acid. If we want to use we want to get like metal sulfate, we will use sulfuric acid. If we want to use chloride, we want to get chloride, so chloride salt, we use hydrochloric acid. So this is how. So the what I call the base from the salt, because the salt is made up of metal and base. So the base is actually come from acid. No, we should say the covalent compound is come from the acid, and then the what I call the metal compound come from hydroxide of metal. So we will always use metal hydroxide with the acid, which kind of acid we want to use depends on what kind of base we want. If we want nitrate, so we use nitric acid, chloride, hydrochloric acid, sulfate, sulfuric acid, carbonate, carboxylic acid, like this. Okay, but normally we won't use this kind of acid like carboxylic one because it's a weak acid. Normally the one that use here is only these three because we want strong acid. So it's only nitric acid, hydrochloric acid, sulfuric acid normally. Okay. Now the next one, potassium. So we use potassium. You see sulfate, right? We want to get sulfate, so we use sulfuric acid. So with the potassium hydroxide, so we will get potassium sulfate with water. All right. So these two. Okay. Done now. All right. Now let's see the what I call the experiment that we want to do. This one is trying to do. He's trying to use what I call hydrochloric acid with potassium hydroxide, phenolphthalein as the indicator. Okay. So now you see what he do. Is first he used the potassium hydroxide solution with phenolphthalein. Then we use hydrochloric acid to neutralize it. So after we neutralize it, the potassium chloride solution now being heated until leftover become the potassium chloride crystal. Then we use the distilled water to rinse it. This rinsing of this distilled water, we only use a bit only. Remember, this one is soluble salt. So we use a bit only just to make sure that some of it are being filtered out. And then the leftover crystal, we dry by using filter paper. So this is the whole process. Okay, can you understand? Huh? Now, in this activity, the phenol, no, I forget already. You should draw the process, the whole process. Okay, at least draw this. Okay, no need too neat. Remember, this is just note. I'm not asking you to like become Van Gogh or something like that. Hugo, no need. 叫我考虑一下，叫我考慮一下。阿樂哥，叫我考慮一下先。哎呀，等等，let me know 啊。Done, huh? All right, so let's see the discussion. So on the discussion, okay, phenolphthalein indicator is needed in titration to determine the endpoint so that the volume of hydrochloric acid needed to neutralize the potassium hydroxide can be determined. So the endpoint is the point where we call what I call that is the point where acid or alkali turn neutral. Okay, so the addition of what the hell is it? Oh, this one, okay, without the phenolphthalein indicator, okay, okay, is in order to prepare the pure salt solution. It means that we use the first one to get the indicator, so we know how much solution, right? Later on, we prepare the other one without there's another one is without the indicator one, right? That one is to prepare the salt only, to prepare the salt solution only. Okay, because why? Because when we try to burn it, the phenolphthalein indicator will still remain in the salt crystal. So that's why we need another one. Okay, do the same process again without the phenolphthalein, so that we can get the salt only. This one only, normally they won't ask. The crystal of this obtained why we rinse in only a liter water. This is to avoid the crystal form dissolved in distilled water. Like I said, we are trying to save as many crystal as we can. Okay, all right, jot this down. Okay. All right. So let's see the second one, where we try to preparation of soluble salt, which is non-ammonium, sodium, and potassium, means other. So to prepare the other than potassium, sodium, ammonium, okay. So acid are used to react with powdered reactive metal oxide or metal carbonate. So we use the powder. So like for example, zinc chloride react with hydrochloric acid, okay. Sorry, if we want to get zinc chloride, so we must use hydrochloric acid with zinc, zinc oxide, or zinc carbonate. If you want to get iron 2 nitrate, so we have to use nitric acid. So you see, nitrate for sure, nitric acid. This one is fixed. The law is fixed. So the only thing is we can use pure iron iron oxide or iron carbonate. While copper 2 sulfate, if I want to get copper 2 sulfate, so we use sulfuric acid with copper oxide or copper carbonate. Why we don't have copper metal only? Because copper metal is highly reactive. So it will automatically become carbonate or oxide. Okay, can understand now? Okay. All right. So this one need to jot down. If you are very familiar nowadays with the formula, the equation formula, you can straight away use the formula only enough. If you are very familiar, okay, you should somehow. Okay. All right. So let's continue. This one only. Okay. 哎，怎么？喂啦。So the second process is similar. So we just skip up. Okay, because the what you call the experiment for soluble salt by using neither the neutralizations or we use the metal and acid. The way of purification is the same. Okay, it means that we use the what you call phenolphthalein to indicate no need, just add inside, get the solution, heat it up to get the crystal, filter out the crystal, rinse it with water, dry it with filter paper. All and the flow is the same. Okay, so now let's see the next one. Purification by using the recrystallizations method. Because the soluble salt, when we form during the preparation, may contain impurities. Some of these impurity might be soluble or non-soluble. Therefore, we need to purify it by using the recrystallized method. Okay? So you see the process is almost similar. We use the what I call the crystal with water, heat it up, and then we filter out the solution is what I call is soluble. So we filter out it, and then the insoluble impurities will be filtered out. Then we heat it up again, and then to get the salt crystal, rinse it with water and dry it. So you see the process almost similar. It's just that we heat it and then we filter it out first before we heat again. Okay? Can not this one first. Okay, so now let's see the next one. Shall we? Okay, how about like this? You draw this one, the difference one. Okay, you draw these two. Then the next one, you just refer back like heating. You just write the heat up. Okay, to get the salt crystal and then distill water and then dry in filter paper like that. Use your own way to write down only enough. Just the first and the second one only. Done, huh? All right, so now let's see the what happened here. So in this activity, why we rinse the salt crystal is to get rid of dissolved impurities. And recrystallization method is not suitable for purifying the insoluble salt because in this method, the salt must be first dissolved in water. And the crystal growth is a method to make the salt crystal form larger. So this is why this crystal growth is actually, have you seen the last, I think quite a lot of years ago, many people like to buy the crystal and then they say, when they will blow something inside, they will burn. That one is actually the crystal growth. Okay? Can I? All right, jot this down. Done, huh? Right now, let's see the next one, the preparation of insoluble salt. So the insoluble salt can be prepared by using the double decomposition reaction. So means that two different aqueous solutions mutually exchange their ion to form a new aqueous solution and a precipitate, like barium chloride with sodium sulfate become these two exchange barium sulfate with sodium chloride. You understand? Means that you see, it's like just now I show you AB plus CD, it become AD plus BC, CB, sorry. This is how. You don't see the bottom one, the bottom one stupid one, that's your textbook one. Your textbook right to do stupid thing. So, or in short, there's another way for ionic equation because we are talking about the what we want is this one. So the half equation or the ionic equation will be barium. What he's trying to show you here is barium ion plus sodium ion. Sulfate ion become barium sulfate. Like that. This one no need lah. This is stupid one. Just this and this. Okay, the chemical equation and the ionic equation. You understand? All right. Done, huh? All right, now let's see the next one. So how they do is, okay, you see the process. Okay, like he used the both solution mix up, and then there will be a condensation, precipitate condense. Okay, then we filter out it, rinse it with what you call with water, and then dry it with filter paper. This one only took out the heating. We doesn't need the heating. Okay, because why? Because the heating is to get the crystal. This one is automatically become crystal, so no need the heating process. Can I? All right, then use your way to jot down this one process. Done, huh? Okay, so let's see if any discussion involved. Wait, so in this process, the filtered barium sulfate need to be rinsed with distilled water. This is to remove the sodium chloride that may presence on the surface of barium sulfate. So you see, the product normally comes out with one soluble and one insoluble. So we rinse it with water is to clean out the soluble one. Can you understand? Because it's soluble, so with water, it will flow down together with water. Okay. Now, the balance equation for this one will be barium chloride plus sodium sulfate become 2 sodium chloride. Sodium chloride is the soluble one with barium sulfate, which is insoluble. So the barium sulfate, okay, the ionic equation is the half equation require the product that we want to show this one. So it's barium ion plus sulfate ion become barium sulfate. So two other insoluble salt that can be prepared by this method will be magnesium carbonate and silver chloride. Okay? All right, so this now. Just now, this one only, we already know. Okay? So the what you call the keep on repeating one, we just skip it. But you need to remember I skip just don't want you to copy so much only, but you still need to remember. Is it I am the only one? Does it feel warm? Do you feel warm? No, so means that I'm the only one who feel warm. So it means that something is wrong with me. Okay. Hello, Dimitri.